I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled OWASP Amass, Discovering Your Exposure on the Internet. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin today. First, all phones have been muted, except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the session. Today's briefing slides will be posted on our website within a few days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our presenter for today's webinar, Mr. Jeff Foley. Jeff is the founder and lead of the Open Web Application Security project called Amass. He has 20 years of R&D experience creating innovative software engineering and information security solutions for real-world challenges. Mr. Foley currently serves as the U.S. Manager for Penetration Testing and Red Teaming at National Grid and is the CTO and co-founder of ClaritySec, an infosec startup. Previously, Jeff was the Director of Research for the Cyber Systems, Weapon Systems, and Sensors operation at Alliance Science and Technology. During his tenure at Northrop Grumman, he built and led the internal penetration testing team and was the program manager for offensive security R&D. Jeff is also very active with several university information security programs and participates in infosec competitions. I will now turn the presentation over to Mr. Foley. Good afternoon, Jeff. The floor is now yours.
Thank you, Steve. All right, so today I'd like to discuss your exposure on the internet and what the OWASP Amass project has taught us about this and some insight hopefully we can share with you about understanding your exposure. Steve already did a good job of introducing me, but I have this slide here that says, yes, I'm the founder and project lead for OWASP Amass and currently serving National Grid as their U.S. Red Team Manager. All right, so we'll get to, these are the three things I'd like to talk about today. One thing I'd like to note, for internet exposure, this talk is focusing on your infrastructure, your organization's infrastructure and internet-facing assets. There's other types of exposure that I will only briefly be mentioning during this discussion. I'm going to go in a little bit into the Amass project. It's not in depth because there's other talks where we've covered the technical details of this project. But I'd like to show how you can use it to understand your exposure. And then the last piece of this discussion, I guess I'm kind of flipping it over to say, so what if you wanted to prevent others from doing this to you? Or I guess you could look at it as, how could you stop something like Amass from enumerating your exposure on the internet? So a couple different ways I'll be looking at this during this briefing. So when I engaged clients over the years, I was quick to ask them questions like, do you know what you look like on the internet? to an attacker or what your organization looks like as a target. And just many organizations simply didn't know, or would say things like, well, we don't have that very well documented. But it wasn't just my experience. I mean, the overall consensus when you're talking to people about this is that that's just the way most organizations are. They don't seem to have a very good understanding right now of what does their infrastructure look like on the internet. And the way I kind of see that is, well, if you don't know what you look like to an adversary, well, how do you plan to protect that infrastructure? Because you don't really know what an attack against you would look like, or how the attacker is likely to approach you as a target, which would make your decision making pretty hard, I would think, if you're trying to prioritize how to defend your organization. And I've gone a little further with some people just saying, well, an asset that's publicly reachable or internet facing is only going to receive the protection it requires if you know it's there and you're staying on top of it or properly managing it. In everyone's defense, I would say that this has become harder over the years because networks are being further fragmented more than ever with the use of cloud solutions and other partners that are handling people's infrastructure for them or portions of it for them. And it can become pretty hard to stay on top of, well, where exactly are we? Or even which partner has what assets exactly. Not that it's a reason not to stay on top of this, but I'll definitely admit it's becoming more complicated. So in order to adapt to this, a lot of organizations are taking on methods that used to be considered offensive techniques or things that the enemy would use, but defensive teams wouldn't typically leverage, like OSINT on yourself, in order to understand your internet presence or exposure. So I list some of these here. DNS enumeration, that's a big one for the Amass project. We'll be getting into that more later. TLS certificate transparency, as that has been pushed, there's been a lot of data that can be collected from certificates. The next two here, or maybe it's more like three, the web scraping, web archives, and use of passive services, or you could bundle that all together by just kind of saying data sources that are out there available that have already done some of the homework, or they've collected this information, and now it's just there for the taking if you know where to go look for it. And it's quite amazing how much of that is out there and available. It's growing every day, really. And then there's just some of your more typical mechanisms like Whois, and people have reverse Whois services where they've collected this information and made it easy to query and look up which organizations have which domain names registered using reverse Whois. And then finally, of course, finding out what ASs or ASNs have been registered by an organization. So regardless of whether an organization leverages these techniques for themselves or to understand their own presence, adversaries are doing it. I mean, this is like standard practice for them to map out a target. And a lot of it does not require or a handful of these do not require sending any traffic to the target until you get into things like the DNS enumeration or pulling the certificates directly off their web servers, which again is not necessarily required using these transparency programs. So we'll keep going. So I wanted to jump right into this just to kind of, in case I haven't been completely clear so far as to what this gives an adversary. You can take all this data collected and turn it into something that's very explorable, like this graph you see in front of you, where in the middle we have the domain, which if we're just looking at a single domain, this would likely be the target you started with. Like today, I'll be showing you what we'll do this against OWASP.org, and actually that's what this is right here. So that red node in the middle is OWASP.org, and then there's various ASNs. That's what these blue nodes are, that they have assets within. So, but just kind of looking at this real quick, you can see there's structure to this graph, and there's portions of their infrastructure that clearly are in the hands of various other organizations. For instance, you can't read what these are on this graph right now, or what the different ASNs are. But for instance, that chunk right there is Google, or the names they have that then point to Google resources that they're using. In this case, for instance, the purple nodes are MX records or mail server records. You know, they're using Google Mail, so that's why this is all showing up. If we look further, we can see that this right here is Rackspace. So they have some things that are hosted within Rackspace, which are these green subdomains. And the orange ones are the IPs that they map to, and then it shows what net blocks they fall under, which then are within the ASN. And I just have one more example. This portion of the graph is DigitalOcean. Similar situation to Rackspace, they have things hosted out in DigitalOcean. But most organizations that you enumerate using things like Amass, when you graph it like this, it creates this useful structure where it makes it rather easy to start picking apart where does this organization exist on the internet. All right, we'll keep going. So what would an adversary do with this? Once they have that graph, so to speak, that I just showed, you know, they have the infrastructure. These are the things I mentioned earlier that I'm not going to go deeper into. I'm just going to mention them here. But once you know what the infrastructure looks like, oftentimes people will move on to using something like Aquatone to do what at least the like bug bounty community tends to call domain flyovers. So you're just grabbing the host page or home page, excuse me, and trying to get an idea of so what's here on this asset. A next step would be using GoBuster to then find out, well, what content exists in that web server. And then there's similar things you can do with like zgrab, where you can say, okay, I want to look at these different applications. Tell me more about like what version of the applications are running there. You know, fingerprint these things as much as possible. And of course, we all know Nmap can be used for things like port scanning. But this is just how they would continue to perform reconnaissance against your infrastructure that they've mapped out. And my argument here is our blue teams need to understand this at least as well as the adversaries do. We can't be allowing the enemy, so to speak, or the adversaries to understand this better than we do, or we're giving up our advantage. But interestingly, that seems to be the case right now. Is many blue teams, if you ask them, do they understand what their exposure looks like or what their attack surface looks like, they can't answer those questions as well as, say, a bug bounty hunter could. So one piece of good news about this is, well, people seem to be acknowledging this and taking action. So in the last, well, actually, I would say in the last quarter, maybe a little bit more than that, some things have been ramping up in this area. A lot of, I already mentioned earlier, a lot of organizations are leveraging OSINT now. But some companies like Adobe have even gone as far as they have open source projects now they've opened up to help other organizations. Well, two things. I see it as they're recognizing the importance of this and sharing that with other organizations. And they've encouraged these other organizations to use OSINT by trying to make it easier for them. The OWASP Amass project is leveraged within Adobe's Marinus project. They described it as they didn't see the point in reinventing the wheel, so they've taken advantage of OWASP's contribution. Also, some of you may have heard how Shodan recently said they've opened this new product offering called Monitor, which offers a very similar capability where they say, we'll just keep watching your attack surface and make you aware when changes take place. And there's other organizations or companies that are, or services popping up similar to this, because this is gaining traction now. I mean, OWASP Amass has been under development for about 1.5 years, and it's been an OWASP project since July of last year. And these changes in the market have happened in the last 3 to 6 months, I would say. But also, other people have been talking about why is this such a problem? Many have said, well, it's because asset management isn't working anymore. With all the fragmentation, it's become hard to get your asset management to stay on top of your presence or your assets. And, you know, people have said, well, internal asset management is a very different problem than external asset management. And there's also been new products coming out to try to deal with this problem with asset management and how we need better systems. But in the meantime, people are embracing these other methods to stay on top of their exposure. Also, the new asset management systems that I'm seeing come out are leveraging, you know, what they call security researcher hacker techniques, since, again, the older ways or the traditional ways of doing this just aren't good enough anymore. So with that, I'm going to cover a little bit about what is this Project Amass. So this project actually just started with me dealing with clients that, as I said earlier, couldn't answer these questions about their own organization. And I wanted to be able to quickly give them something to look at and say, well, this is what you look like to a adversary. So I started automating this process since there didn't seem to be very good tools out there to do this. But when I realized that there definitely just were not very good tools out there, and there were a lot more people that wanted this capability, that's when I decided to open it up as a contribution back to the infosec community. So what it performs is in-depth DNS enumeration, which, like I said, I'll get a little bit more into that later, or at least I'll touch on it here when I mention this architecture, how this works, and then we'll talk about it more later. So it automates reaching out to all these data sources and bringing the data back to one place where it can be analyzed and more can be discovered from it. It also, as you saw a little while ago, allows for visualization of the findings. And a recent addition to this project is that you can collect the findings over time, and it will show you changes that have taken place to an organization's exposure. And I have an example of just how effective this really is later on when I talk about some observations we've made from this project. But discussing this architecture, there's a key element to this that makes it far more effective, I would argue, than some of the other tools that exist out there that try to do similar things. And it's the part of this graph where you see the cyclic relationship here, where it takes the DNS queries and the resolved names and brings them back to these other services, like giving those resolved names back to the data sources, attempting to do permutations on the names using the alterations service here, and then just brute forcing against the names as targets. That recursive relationship where they all can feed on each other's findings causes this project to just get far greater results than other tools that have attempted to do this before. And I guess you could also say that it's just the sheer number of data sources that we reach out to. I think we're over 40 now. And some of these algorithms that we use for altering the names are, well, I think it's safe to say, since I've done a little research on this, they're the most advanced for any tool like this. And because we go as far as to use algorithms similar to what password crackers use, where we are generating similar names in an attempt to stay consistent with a target's naming scheme, but making the necessary mutations so that we can discover new names. And it's quite effective. We use a Markov model to achieve this, and you can find out more about it at the project repository. All right. So there's a handful of experts within the community that have been leveraging this OWASP project. As I've already kind of foot stomped, we've been trying to get blue teams to use it to understand their own attack surface. There's an obvious desire for red teams and penetration testers to use this to make sure they understand a target organization's attack surface, or to make sure that they understand all of this, what's within scope of their engagement. And actually, one of our largest communities or user communities are bug bounty hunters, because this is reconnaissance is a very big part of what they do, and this tool, according to them, saves them a lot of time so that they can focus on the actual bugs that they're trying to discover and not just finding targets. So they seem pretty grateful for this. And then finally, investigators and intelligence analysts that use OSINT seem to like this tool as well for hunting down, well, whatever they're investigating on the internet. assuming this all works out right, I was going to give a quick demo against OWASP.org just to show you on the command line, what does this look like? Let's see if it wants to let me. All right. So what I'm about to show you is very simple use of this tool, and on purpose I'm going to use it in such a way that it doesn't take very long to do this. But there's some advanced features that can be, well, for instance, just to get an idea, it's a fairly flexible tool with a lot of options.
Jeff, is there any way you can expand that image? It's kind of tiny. It's quite an eye chart right now.
I'm not sure. I'm not sure it gives me any control over.
Okay. Okay.
Yeah, my apologies, but where was I? Yeah, so as I said, real quick, we'll see what this does. So when you first execute this, it goes out to the data sources it knows about and starts just trying to pull as many names as it can find, and then begins the DNS enumeration. And that's why you're seeing, okay, so we've got certificate, transparency, finding names, we're resolving the names, we're finding some more from some of these other sites, like it has Dossier, Threat Crowd, Common Crawl. Eventually, when it's, so OWASP.org is a very small target, which makes it very useful for a demonstration like this. But eventually, when this comes close to completing, it should start throwing out some altered names. We'll see if it decides to, or if it gets lucky enough. That's the usual flow. Also, if there's brute forcing going on, it will start that process, but it will wait until there's availability, I guess you could say, with the DNS resolvers before it starts really asking for a lot of, or performing a lot of queries. Since it doesn't look like it's going to find much more, I'm just going to bring this to a close. So when the enumeration completes, it creates this little summary, which I find pretty useful actually, where it says, okay, there's this many names that were discovered. Here's the different methods, or yeah, pretty much like methods that were used to acquire those names. And here are the different ASNs that they fall into, and the different like CIDRs or net blocks, which can make it easy to see, oh, okay, so they had this many, and using this cloud service or this service provider. So I find that pretty useful just to get a quick glance at what does this target look like. So I just wanted to show that so that at least what you all could see is what this looks like to most users, because this is how currently, at least, a lot of people are using this. They're just firing it up on the command line, and the results can be collected from either JSON files or text files that we create. They can be pulled out of a graph database that is created as part of this process. And there's some pretty advanced things that you can do with this. Like if you're trying to deploy this in the cloud, there's ways to connect you can use, for instance, Azure's Cosmos DB as your graph database, and it allows this to become a more scalable activity where now all the data can be collected into one place. It can be easy for everyone to get access to it, do further analysis on it. And well, later I'll talk about some things that we plan to do to further support that. For now, I'm gonna go back to the slides. All right. So I threw this in here because one thing I wanted to note is sometimes these organizations have a lot of exposure and the results can be huge. Like you probably can't see the number very well with this picture, but there's over 30,000 nodes in this graph right here. And most of the graph rendering systems that this project supports are not very good at rendering a graph of that size. But we've spent some time working with this organization called Graphistry, who has a service where they can take all your data, they bring it out to their cloud environment, and they'll render you your image. And that's where this came from. It's quite amazing. And I still find it very useful to have the structure of the organization at my fingertips, or maybe I'm just a very visual person, but I find that helpful to have. So, I mean, for anything that's under, I would say 5,000 nodes, you can probably get D3 JavaScript to do it. There's, I believe, Gephi is a pretty powerful tool for this that ingests the GEXF format, which we can output. So there's other options when you're dealing with a smaller number of results, but sometimes you need more power to get it done. This is a popular option right here. The data collected from Amass can be exported into a format that Maltego can import. And it gives you the whole entire, so this is not a transform, in case you're familiar with Maltego. This isn't where you put in, say, OWASP.org and do a transform. This is where it just says, here's your entire graph as a starting point. So this data all came from essentially the same enumeration that I just executed as part of the demonstration. But all the data was turned into a CFV file that then was imported to Maltego. And this can be such a great place to begin. Instead of, well, for a couple of reasons. One is the transforms that Maltego comes with out of the box will not get you this many results. And you just don't have to go through the trouble of starting with the domain and then trying to get all the names and then trying to get all the IPs. And instead, you just start with all of this, and you can continue your investigation just with the portion that's relevant to what you're trying to accomplish and save time and have more accurate results. So there's a lot of people like myself that like using this for further exploration. So this was something I was really looking forward to sharing with everyone. because these are things that I've noticed and some other people involved in this project have noticed over the time that we've been developing it, testing it, what have you. It's really, to me, it just seems amazing how many names pop up when you're doing these enumerations for an organization, and they're extremely revealing to what the purpose of the asset is. Now, of course, some people would say, well, we needed to say www for the website. But what I'm referring to is, if you name your asset admin something, dot your domain name, you might as well just say, adversaries, please come here and attempt to take over this target. You're begging people to try to exploit that target. It's the same thing with a lot of people name assets test dash something or something dash test. Test targets make excellent, low-hanging fruit for an adversary, and they just probably shouldn't be publicly exposed, period, unless you're really confident in their current state. But if anything, I would recommend don't name it that. You're only encouraging people to come to it. But we see this again and again all the time. It's quite incredible. Also, we've performed some very, I would say, borderline nasty brute forcing enumerations against some targets, and it just amazes me how even after hours of this going on, they still don't notice the activity and don't throttle our activity. You would hope that the target would be watching DNS enough to just eventually say, what's happening here? Why is this happening? And, if I were them, I think I'd encourage them to block the target or, the adversary that's generating the traffic, or at least throttle it so it becomes inconvenient to do the enumeration. So that's another one. And then this one that really caught me off guard when I noticed what this meant, because at first I overlooked this whole wireless devices situation. So some organizations that have, I imagine it's their guest wireless network, they have the names of these devices publicly exposed, which I don't know why they'd want to do that, but they are. And so earlier I mentioned the tracking capability that this project has. So for one of our test cases, they had this situation going on where they had wireless devices on a dynamic network that was publicly exposed, and we were doing numerous enumerations like back to back, and then using the tracker to see the changes from one enumeration to the next. And what we noticed that we certainly were not expecting is that some of the assets that popped up were cell phones. So people that were coming into work and their cell phone went onto the guest wireless network and then popped up into this publicly exposed namespace, and their first and last name were on the name of the device. So it would say first name, last name, iPhone, and then DYN, domain name. And when they left the facility, we were able to see that as well. And this, to me, I couldn't believe it. I was like, wow, so we're just using this publicly available information, OSINT, and we're able to watch when people are coming to work and leaving work and getting a pretty good idea of who they are. I found that extremely concerning. And it really, I think, goes to show how everyone needs to get a better handle on this exposure and consider what it really means to be exposing these names to the public. So in case this is made you interested in wanting to play with this, I threw these links in here. You can always, of course, go to our the OWASP project page. There's some good starting point information there. If you just want to jump right into getting this on your system, I would say go to the repository. There's instructions there on how to obtain the tool. And also, if you're already using Linux, especially if it's say Ubuntu or something that has support right out of the box for Snap, we have a Snap package. Also, if you're on a Mac OS system, we have a homebrew package. There's all sorts of ways to get your hands on this. There's packages I don't manage as well. There's community support, like FreeBSD has a package for Amass, and there's other ones that I probably just don't know about. I think Arch Linux and Black Arch, I think they both have packages for this. So yeah, I'd recommend you go to these links, and you can get a lot more answers to the details of this project. So moving, like I said, into a bit of a different topic, instead of it being understanding, what is exposure, why is it important, how can you, better understand it, this portion of the presentation was really focused on, well, what if you wanted to try to prevent it? What if you took some time to look at your own exposure and you decided, yeah, this is concerning, we want to consolidate our own exposure, and we'd also like to make this a little harder for other people to do to us. So we've learned some things about that from this project, as you can imagine, and I would like to share some of those with the audience. So some of these I go into further detail about. Some of them I'm just going to mention here. But the obvious one is this top bullet here. Reduce the number of internet-facing systems. If it doesn't need to be, for instance, when I enumerate some of these targets, they have private IP addresses that are showing up in publicly available DNS records. There's just no need for that, right? If your system isn't being accessed from the outside, then don't tell us about it, would be my recommendation. Keep that internal so that you're reducing how easy it is for people to be mapping out your infrastructure. I already kind of covered how, and I'll talk about this a little bit more, about the less revealing naming schemes. Here's one that I'm just going to touch on here. So DNS Sec, some of you perhaps are familiar with this already. If you're using NSEC, not NSEC 3, but NSEC, then you're likely to be susceptible to what a lot of people call zone walking. It's also called NSEC traversal. But someone can map out pretty much your entire zone by walking your NSEC records, or your NSEC information at least. And what I'm really recommending here, I guess, is either make sure you're very comfortable with what your public DNS is saying about your infrastructure, in which case I guess you wouldn't have to worry about people walking the zone, because you'd be comfortable with what the zone says. But if you do not want everyone knowing what's in your zone, then I would recommend at least going to NSEC 3, maybe something more extreme like not using NSEC at all, which everyone has to make these decisions for themselves, but at least be aware that NSEC can expose the records in your zone, or at least the names within your zone. And even NSEC 3 can be walked if people can perform the correct hash cracking. So there's risks that come with it. As you saw earlier during the demonstration, and I mentioned it, certificates reveal names. I'll talk about this a little bit more later, but the takeaway here, I guess, would be try to reduce how many names you're putting into these certificates. If it doesn't need to be there, then I wouldn't put it in. Pointer records, I talk about this a little bit more later as well, but it's just, I guess I'm starting to sound repetitive. If you don't need them, then don't make them available to the public. The DNS Wildcards, I'm going to explain that later. That's a pretty good one that I feel like a lot of people I speak with, they don't understand the value of this, so I'm going to talk about it in a little bit. And then, of course, just to start watching this unusual DNS activity. If you watch for reconnaissance, you can get ahead of the targeted attacks. All right, so the naming scheme. You already heard me say my piece on, why is this a problem? What is this doing to you that perhaps you don't realize? I mean, a lot of people, when I speak to them about this, they just say, well, we didn't think people could see those names. In which case, I guess I could see why they wouldn't be worried about it. But a lot of these names can be acquired. And then, like I said, naming them things like admin makes them very attractive as a target. I've seen some interesting research where people have proposed, well, if you don't actually need the name to be obvious as to what, or easy for someone to remember or something like that, if this is just something that has to be publicly exposed, but no one really needs to know what it is, or needs, it's just computers talking to other computers, then these other schemes have been proposed, like using ID numbers, perhaps in front of a facility acronym or name, and then domain and top-level domain. So that way, it only means something to you. I mean, sure, someone can find it, but they're going to see it and say, well, it looks like every other ID number I'm seeing. How do I know where to begin? And they'll have to move on to things like further fingerprinting of the target, like I mentioned earlier, with the flyovers and application scanning and things like that. I think this is a great idea. I think it makes it a lot harder for someone to start making decisions about you as a target. But of course, it requires a lot of organization and changes possibly to the way you're handling your namespace. Yeah, so for the certificates, what I notice here is there's a lot of times the people managing an organization's certificates are often not people involved with security. So the people that are putting the names into the certificates usually, I think, are just thinking of it more from a convenience perspective, or like what they would need to operate the web assets that they're dealing with, but they're probably not thinking as much about the exposure that it's creating. And there's oftentimes a disconnect between the two groups within an organization. But I think a security, like a blue team, should be trying to stay on top of, so what are the names that are being put into the certificates so that they can stay on top of what their exposure looks like. A lot of times these names show up in the subject alternative name section of the cert. So my recommendation here would just be to make that part of how you're monitoring your own exposure and reduce the names as much as possible to what you actually need. Yeah, so the pointer records are interesting. In some places, they need to be used, so there's probably no getting around that. But I've seen a lot of organizations where they clearly just have more of these than they really need. They're someone just decided to make a lot of them, or for every name they also made the pointer record. But what's really, and I've also, talked to people about how there's systems they have set up for, like I have here, logging and monitoring, where it just makes it easier to have the pointer record. But if you leave those there, it makes it trivial for an adversary to do these reverse DNS sweeps, where they just say, oh, here's the CIDR of interest, and they just go across every single IP and start pulling all the names that they get from reverse DNS. It's an incredibly powerful technique. I even did this bit, I don't know, last year I think it was, about how if you use reverse DNS, or sorry, if you use alterations of names to come up with new names that then get you into new like net blocks or CIDRs, and then you do sweeps across the whole entire CIDR, that, and then feed those names back into alterations, that process tends to keep feeding on itself, and you can find so many names for a target organization using what I just called alt and sweep. So I would really recommend that everyone reduce how many pointer records they have in their zones. All right, this is an extremely powerful one. If you're going to take something away from this talk, I might say it should be this. DNS wildcards are the bane of these tools, at least for DNS enumeration. It's absolutely necessary that a tool like Amass has to detect all the DNS wildcards in the namespaces that it's working within. Because if you don't accurately detect it and you start shooting, say, like brute force attempts at it, and it keeps coming back saying, yes, this is a valid name, this is a valid name, you'll just end up with so many false positives that it ruins your enumeration. So it's really important that these tools detect it, but also when they do, what they tend to have to do about it is just say, all right, if we don't have a reason to believe that this name is valid and it falls into a subdomain that has a wildcard, then we just aren't going to attempt it. More accurately, what really ends up happening is once you detect the wildcard and you know what the wildcard points to, every name that comes back from a query that maps to that same information that the wildcard record points to, you just end up writing it off or throwing it out. But because of that, it creates this hole, I'm calling it, in your namespace, like where even if the adversary is looking there, they just may not be able to get anything out of it. So if you can use this more tactically within your organization or your infrastructure to try to create these holes all over the place, you can really reduce how much an adversary can glean from your infrastructure. So I'd really consider using that. And then, of course, just watching for abnormal levels of activity, which I realize this can be an interesting problem. DNS is interesting to try to wrap your arms around, but some of this I think wouldn't be too hard to, like a safe approach might be, just look for unusual levels of activity and then throttle on that activity. That way you're not really denying them access if that's too harsh for your organization, but the throttling should not really be a problem if they are staying within typical behavior or usage of your resources or assets. So I just think everyone should be considering DNS more than just part of their like a mechanism or part of their infrastructure. It's something used as part of the attack, and it needs to be watched that way. Yeah, and if you were to use it to your full advantage, really you could get ahead of these targeted attacks that are looking right at you and trying to figure out how they're going to execute their operation against you. All right, so closing up, you know, like I said, your assets, your public-facing assets, are only going to be protected properly if you know they're there and you're managing them properly. Your blue teams will definitely benefit by knowing about your the changes to your exposure quickly instead of finding out the hard way. And some of these practical measures I mentioned of like things you could somewhat quickly implement within your organization to make reconnaissance harder for adversaries, I would really recommend more people employing these techniques. And with that, we'll open it up to questions.
Okay, well, thank you, Jeff. That was quite an interesting presentation. I think it's really kind of like kind of the first step, the first line of defense, in the process. You need to know what you look like in order to protect yourself, and you want to minimize what you have to be showing out there. And so, like I said, I think this is a key step in the process. So I guess one of the things I'm curious about is so you kind of told us where you are, what you've done, how you've used it so far. How about future directions? Do you have any plans to continue to develop, enhance the Amass tool? Is there do you have anything coming down the road that we should be looking out for?
Yeah, absolutely. So in addition to some typical things we're just always trying to do, like making it easier for people to use and working on interfacing on a more grander scale, though, people have asked to be able to execute this in serverless environments. So they want to really be able to scale this, right? Where they can say, I want to fire off 50 of these and use like a REST API to send them the enumeration configurations and then pull it all back to, say, a central database. Because people have used this, and of course they like it at the command line or even scripted, but they want to really take it to the next level. So we're looking into how we could, or what the right REST API would be for this, so that we can allow people to deploy it in that fashion.
Okay, sounds good. So we do have a question from one of our audience members, and they're wondering, would having a single purpose cert per service give the same defensive effect as a wildcard cert, just with administrative overhead?
So did they say wildcard cert or DNS record? Because
the question said wildcard cert, but
yeah, because in this case they're not the same thing. I mean, there are wildcards within web servers as well, which create a similar challenge for an attacker. But in this case, wildcards in a cert can be like pulled out easily, or just like I just take the asterisk off of it and use the remaining name. But the wildcard that I was hoping to encourage people to use is a DNS wildcard record, which is the one that you could say is the fishnet, or the, you know, it's what catches all the queries that don't specifically match to a existing record, catches all those queries and says, sure, this is a good name, and it gives you the same answer every time, like this is the IP for it. So I don't think you can address that in your certificate or TLS certificate.
Okay, great. Thanks for clarifying that. Appreciate that.
Or if I'm wrong,
see.
Maybe they can bring it, ask another question or clarify,
okay,
or something like that.
Alrighty. So there's another question. So do you have any plans for efficient continuous attack surface mapping?
Continuous, what was that? Continuous what?
It says continuous attack surface mapping.
Yeah, that sounds pretty intriguing. I mean, no one has actually approached me about that, but the closest thing I guess we have to that is the tracker, where we can continuously perform the enumerations, and then by using the tracker, we keep getting the changes. So it shows if the target is that dynamic, it allows us to quickly see the changes they're making. And in some cases, for instance, cloud assets move around quite a bit, so this is very useful for that. Also, some organizations that have networks where they're actually setting up operations, you can watch them preparing an operation using this capability. So I don't know if that maps quite to what they're asking. This could be something fun to take offline if any of you want to take these questions to our Discord, or if you go to our project repository, there's a link there for chat, which will take you to the Discord. And it'd be great to have some of these discussions about possible directions or feature requests and things like that.
Okay, and that's at the OWASP site, correct, Jeff?
Well, I think the easiest way to find it is if you go to the OWASP Amass repo that's on GitHub, the README file that shows up kind of like the home page for the repo, right at the top there, it has a link for the chat, and it'll take you to the appropriate server where the discussions are happening.
Okay, good. I just wanted to clarify exactly where the folks should be looking for that. Let's see. There's one other question that came in. Wondering if you'd recommend the Amass for honeypot monitoring cases.
So, if I could ask, does he mean monitoring your own honeypots or someone else's?
Internal use.
Okay. Yeah, so, well, just to be clear, this tool cannot really be used inside your network. And what I mean by that is it won't monitor assets that are not public facing or internet facing, but you can execute it internally. Like you can be sitting at work and run this, and it will give you the external perspective. So as long as your honeypot, of course, is on the outside, which I imagine it could be, or maybe it's not. But if it is on the outside, then it would allow you to keep seeing where it exists. But otherwise, I'm not sure what kind of monitoring you're referring to, because probably the most this would tell you is that it's still there, or it's at the same IP, things like that.
So it's gonna let you know it's there, but it's not going to monitor the activity at that node. Is that correct?
Right. There's no Amass. The scope I've put around this is that we do not say like scan, like do banner grabs or port scans or anything that pull data from applications. We're just discovering what networks assets are on. So we get names, we get IP addresses, we find out what networks they're in, what ASNs those are in, to show where you are on the internet. There's other great tools out there that then go deeper if you want to watch what's happening on an asset.
Okay. All right. Well, I think we've covered the questions that have come in from our attendees today, and so once again, Jeff, I want to I'd want to thank you for sharing your time and your expertise with us. Like I said, I think this is it's an important tool. I appreciate the work that you've done on this, and like I said, really making it open source and available to the community to use. I think that's a great contribution to the community, and we appreciate your efforts in this endeavor.
Yeah, thank you very much. It was a pleasure doing the presentation.
Okay.
Feel free to,
well,
one last note, if any of you are feeling tempted to participate in this project at all, please, again, don't hesitate to come to the chat, and we're always willing to discuss new contributors. So thank you very much.
Okay, thanks, Jeff. And I'll make just one final note. On our next webinar will be coming up right after the Memorial Day holiday. I think it's going to be the 30th. We haven't, 29 or 30th, but and we're going to be, in that one, we're going to be looking at a tool. It's called a binary file application scanner, and that's a tool that'll help you find things like PII. Trying to discover, stuff you may not know is there, and you may not want to disseminate to the outside world. So this is kind of a tool to help, keep you from spreading information that you don't want to send out inadvertently. So we'll be sending out an announcement once we nail down the exact date for that. But like I said, coming up the week of the Memorial Day holiday is the current plan. So okay, thanks for joining us, everybody, and we'll see you in the future. Thanks. Bye-bye now.